And welcome to this video that is going to talk about reference angles in trigonometry. I have to let you know that at the start of this video, if you're here, I'm assuming that you have a great sense of what standard position is and what the initial side and terminal side of an angle in standard position are. Those vocabularies have to be pretty well fluent at this point, or this video is going to be a struggle for you. The video is going to break out into the following 4 areas, and feel free to use the zooming features on the time signature to be able to go right to the part you'd like to see. Those 4 parts are going to be the definition. I'll do a sketchpad demo, and then I'll do some formula development and take you through some example problems. Okay? Okay, so let's start with the definition of reference angle. And the definition that we're going to use here is the following. It's the smallest measure between the terminal side of an angle in standard position and the x-axis. Okay? So, you'll have to have a sense of going from the terminal side to the x-axis and taking that measure. You should be able to do it mentally in a lot of circumstances. It's a little tricky when you're in radians, but once you get a knack for this, you're going to be great. And we're going to develop the formulas for it too, if all else fails. Okay? So here, you need to know that it's always positive, the reference angle. Okay? Even if the angle you're given is a negative angle measure in standard position, the reference will be positive. Okay? And you also need to know that the reference angle is always between 0 degrees and 90 degrees, which is also between 0 and pi halves radians, okay, if you're dealing with radians. Okay? So, that being said, let's take a look at this sketchpad demo that I concocted here to give you a better sense of what we mean by reference angle. Okay? So, if you notice here, I'm given this angle in standard position. It's angle ABC. It's 45 degrees. And if I showed you the reference triangle in which the reference angle lives, it would also be 45 degrees. Okay? Well, that seems pretty easy, I guess, right? Oh, it's whatever the angle measure is. Well, that's only true in the first quadrant. Okay? So if we had a 28-degree angle measure for ABC, the reference of ABC is also 28 degrees. Okay? Similarly, if we had an 80-degree measure, its reference would be 80 degrees. Now, why is that, you might ask? Well, you probably can see that the closest distance, or the closest trip we can take from this terminal side to the x-axis is, in fact, to just go back through the first quadrant and hit the x-axis. Okay? So, how does that work in other quadrants? Well, let's take a look. If we're over here at, let's say, 120 degrees, okay, we would see that the smallest angle measure between this terminal side and the x-axis would come from going from the x-axis to the terminal side this way. Okay? So in the first quadrant, we went over here, and now we are working from the negative x-axis. So you should probably be able to see that from 120 to 180, it's no shock that it is a reference to 60. Now, I'm going to also show you this piece here, as you're probably thinking 60 over here, and that makes sense. 60 is the measure of the reference angle. However, often we draw the reference angle in the first quadrant because we think of it as in standard position as well. Okay? So, you'll see here there's a relationship between this red number here and this pink number here. They're always going to add up to 180. Okay? So if you notice here, if I went to 135, now this associated triangle is 45, so the reference is a 45-degree angle in the first quadrant. Okay? Similarly, if I came all the way up to 179, it shouldn't be a shock that, well, there's only 1 degree left to get to the 180, and the reference angle is, in fact, 1 degree. Okay? Well, it's going to work similarly, but a little different once I get into the third quadrant. If you notice here, let's take a look at a angle measure of 220 degrees in standard position. again, if you notice where the mouse is, I'm tracing the rotation of the angle that's in standard position here, okay, uh, with this red marker, this tick marker here, okay? So we have a 220 degree angle, which makes sense that the gap between 220 and 180 is just 40 degrees, okay? So the reference angle is in fact 40 degrees. Okay, I'll leave both on for a second here, and I'll just come back to 190, and it shouldn't be a shock to you that when the angle is positioned in standard position in 190 degrees, there's a 10 degree gap between the x-axis and the angle's terminal side, so the reference angle is 10 degrees. Similarly, if I came to 260, we would know that there's a 80 degree measure between the x-axis and the terminal side now that has a measure of 260 degrees. Okay, so the reference is 80 there. Okay, so now I'm going to take us over here into the third quadrant. I'll turn the associated triangle and the reference angle off for a second. I'll give you one that's decently easy here. An angle measure of 345 in standard position. Again, if you're watching where the mouse is tracing, 340 degrees is almost one rotation. And then the nearest trip to the x-axis is right in here. Okay, so that measure to go from 345 to 360 is going to be 15 degrees. So the reference angle is in fact 15 degrees. Similarly, if I were at an angle measure of 315 degrees, this gap would increase to 45 because I've gone backwards. Okay, and if you notice here, there's a relationship between 360 and 45 and 315. We'll talk about that when we develop the formulas. Okay, so let's continue to look at this, but let's look at it in radians now. Okay, and I've done some things to help myself in concocting these angles so that they're decently nice angles here to deal with. So I'm going to show that we have this angle measure. It's of pi quarter radians. Again, if it's in standard position, it's in the xy plane. Okay, and then I have a bunch of angles already made here. So I'll go to pi 6. Okay, so if you notice the angle measure that's closest to this terminal side to the x-axis, again in the first quadrant, is just itself. So the reference is pi 6. And if I went up to pi thirds, similarly again, its reference is itself. Always the case in the first quadrant. Okay, so let me go into the second quadrant here. Let me go over to 2 pi thirds. Okay, so again, we're looking here. We want to see that angle measurement from the x-axis to the terminal side that is smallest. It's obviously not going to be itself because that's an obtuse measure. There's this acute side here, okay, that we want to put our focus to. Okay, so if we have 2 pi thirds to here and we know that this is pi, which is equal to 180 degrees, we just try and get ourselves to think in thirds here and say, well, if you're at 2 pi thirds, how many thirds more do you need? Well, it shouldn't be a shock that that in fact is just 1 pi thirds, or just pi thirds radians, okay? So the reference angle here is in fact pi thirds, okay? Also, if you notice here, if you wanted to take a look at something like 5 pi 6, okay, now we're thinking what, in 6? So you ask yourself, well, if I have 5 pi 6, how many more 6 do I need of a pi to make an entire pi radian measure? So it would be 1 pi 6. So the reference here is just pi 6. Okay? So now what if I took a trip down to 5 pi quarters? Okay? Well, again, I'm looking for the closest measure to the x-axis, which will be this measure here. Okay? And I've got to force myself to think in quarters. Okay? So if I'm in quarters, I want to think of this as 4/4 pi, or 4 quarters pi. And to go to 5/4 pi, it should make sense that I only need another pi quarters, which, if you notice when I put the associated triangle up, the reference triangle, it is in fact pi quarters. Okay? So let me move over into the 4th quadrant for something like 11 pi 6. Okay? And you'll see here that I'm thinking in sixths, but it's probably a good idea for me to recognize here that this is 2 pi, also known as 12/6 pi. If you just notice mentally, you're going to wind up with 2 here if you think in 6 by saying 12/6. Well, if the angle is 11/6, this measure here should just be 1/6 pi to get us up to 2 pi. So if we show the associated triangle, you could actually see, in fact, that it is pi 6 radians, and therefore the reference is pi 6. Okay? So let me just do 1 or 2 more examples here. I'll just try and verbalize them instead of drawing. Okay? So if you notice here, if you have 4 pi thirds, okay, that's past pi, and then I'm thinking in thirds, so I'm thinking pi is really 3/3. So how much further is it to 4/3? It's just 1/3. So to go from 3/3 pi to 4/3 pi is 1/3 pi. So it makes sense that that reference angle is pi thirds. Now there's probably something you've seen here in your mind, if anything, and I show it to help people visualize this, and it's kind of the idea of this bow tie, okay? That all the angle measurements that you could possibly ever be looking for are inside this bow tie here, okay? So if you notice here, even when I rotate this around, there's this bow tie shape still going on no matter where I rotate the angle in a standard position, okay? So inside the bow tie is where you see that we're going from any terminal side to the x-axis. If you never notice, we're never going to the y-axis, okay? It's inside the bow tie. And again, that bow tie exists even if you are in degrees. So you have to be conscientious of being able to find the closest and smallest angle measure from the terminal side to the x-axis. And if it's not something you could draw a bow tie around, you're probably doing it incorrectly. Okay? So now let's take a look at some formulas, if you will. So I want to turn the Smart Tools on just for a second. Okay? And now we're going to look at some formula development. Okay? So let me turn off these bow ties, and we'll take a look here. Again, if you notice, here we said in the first quadrant, the reference for any given angle theta is equal to itself. So the formula in the first quadrant is just theta. Okay. Now in the second quadrant, you're noticing what? Let me make this easy here. It's always so easy to mentalize this around the idea of like 10. Okay. So you're saying that we have a 170-degree angle measure here in red, and the reference is 10. So how are we associating 170, 180, and 10? Well, to come up with the 10, if we're starting at 180, I hope you can see that it's 180 minus the given angle of 170, which is theta. It could be anything in the second quadrant, anything between 90 and 180, not including 90 and 180. So this seems like it would work. We do 180 minus theta is 10, okay? And if I had, excuse me, wrong tool, if I had something like 180 minus 120, I would get 60, okay, by again putting the given angle measure in here for theta, so that's a great formula, okay? And then what happens down here in the third quadrant? Okay, well, I'll give you a 10-degree reference, which means the angle is 190. So how do I use this idea that I'm at the 180, I'm given 190, and I need to come up with 10? Well, here, the only difference is you're going to start with theta and subtract 180. So it's the same as the second quadrant, but in reverse order. And we see that this works. So if I did 190, which is the given angle up here, minus 180. I would in fact get the appropriate reference, which is 10. And what if I in fact had something like 240? Well, 240 in for theta minus 180 gives me the appropriate reference of 60. So what is it when I'm over here in the fourth quadrant? What if I were here getting a reference of 20, because my angle measure were 340? Well, again, you know the positive x-axis is a measurement of 0 or 360 degrees. Okay, so I've got this idea of 360, given a 340, I need to get 20. Well, that sounds like, from a formula standpoint, that I should start with 360 and subtract the given angle of theta. So that seems to work, because I gave you 340, and 360 minus 340 is 20, which is the correct reference. Okay? So if I took it back to 300, would that work? Yeah, because 360 minus 300 here for theta would give you 60, and you can see that the reference is, in fact, 60. So we have here, I'll just come out of this page. So we've got these formulas here for the reference angles if we in fact have degree. So to find the reference angle in the given quadrants, you're using these formulas. So for Q1, Q2, okay, then you've got Q3 here, okay, and you've got Q4 here. Now if you notice, this only works if the angle is in fact positive. I'll give you some examples later where it's in fact negative. I'm going to change colors here to go to radians, okay, and I'll put red in radians. We see blue for degrees here, okay. Well, quadrant 1's not going to matter if it's in degrees or radians. It's still going to be theta. And you probably guessed that I could figure this out by formula by just converting 180 to pi. So this will be pi minus theta, which is the same idea, just in radians. And this will be theta minus pi. Okay. And in the fourth quadrant, 360 is equal to 2 pi. So it's just 2 pi minus theta. Okay. So where does that leave us? Probably leaves us with wanting to do some examples. Okay, and I'll do some with these formulas. So we'll go to the next page, paste, group. Okay, so if you're here, you've seen how we have developed these formulas for the reference angles. Okay, and so I'll ask you, what is the reference of, and we'll do a couple examples here. Okay, so what do we have here? Let's say, what's the reference of 84 degrees? Well, that's easy because it's in quadrant 1. Therefore, the reference is 84 degrees. Okay? So what if we in fact had something like 305 degrees? Well, 305 degrees is in quadrant 4, so I'll use the quadrant 4 formula and think it's 360 minus 305 is in fact 55 degrees. Again, it's a 55-degree angle measure that would be in standard position in the first quadrant, would be the reference triangle. Okay? So now here, what if I had a angle measure of 3 pi quarters? Okay? 3 pi quarters rads. Well, you'd have to realize it's almost 4 quarters, but not quite, so it's in quadrant 2. Okay? So using my quadrant 2 rule, I would do pi minus 3/4 pi. Oh, excuse me, wrong symbol there. Okay, so it's pi minus 3/4 pi. Well, you would probably want to think of this as 4/4 pi, so you can get equal to 1/4 pi. Okay? So, trying to end up on a couple more examples here. What if we had something like um, negative pi thirds rads? Okay, well, you can't really do the formula there. Um, but if you notice from a sketch standpoint, you can't really do the formula because it's negative. So if we had this being our negative pi thirds, okay, its reference angle would be pi thirds because its distance between its terminal side and the x-axis is pi thirds. Okay, so we would get pi thirds radians for the reference. Okay, so you really need to have a sense of how to do this quickly. You can always go with these formulas and memorize the formulas, but this should have a feel to it. Okay, you should sit there and say, oh, if I'm at 162, I only need 18 more degrees to get to the nearest x-axis. Okay, so work with drawings, work with sketches. A sketch to start out can have you orient yourself to where the nearest x-axis is. You probably be able to do these mentally. Okay, so I hope that's a good explanation and enjoy and practice and feel free to tell your friends.